Hey everybody, this is Larry. This is day 20 of the LeetCode October challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Kong graph. Given a reference of the node connected undirected graph, return a deep copy of the graph. Graph looks the same. You can return the same graph. The nodes were Kong, but the graph is messed up, doesn't have the same connection. I guess that makes sense. Okay. Okay. I think you could do this a number of ways. You could do it in depth first search, breadth first search. As long as you don't process the same node more than once, then it should be okay. It's kind of a weird problem. I don't think I've seen something similar, but we can give it a go. But I think this is just a very basic, like, process each node at least once, and practice, and that's probably pretty much all we need. Yeah, let's kind of, and node is unique. Okay, let's get started then. So we just keep track of scene in a set somewhere, and then maybe we have a process thing, which is just I want to say node, but current node. Current. Let's call this I don't know, root, so that's a little bit less confusing. But we'll process a node, and then basically we want to process root. That's what we want to return, and this should return a node, right? So yeah, and we just want to keep track by the value because that makes it easier, but maybe we could just keep track of the node in general. So yeah, if node is in scene, return node. I guess we could cache this instead of just thing. Let's go as cache. Let's make it a dictionary. If this isn't cached, then we just cache node. I haven't really decided on the API yet, to be honest. As you may know, I'm solving this live, so this is how I may talk through solving a problem. But basically, my idea is going to be that it's depth first search, and then I'm going to process one by one. The API is a little bit iffy. I'm still working it out, so definitely bear with me and let me know. Let's see how it goes. And ideally, everything should be linear. But yeah. So then, otherwise, we create a new node. So new node is equal to node with the value of node.value. And I guess we have to construct the neighbors one by one. We can't just copy it because these are all nodes, right? I think so. It's not clear what neighbor. Oh yeah, it's a list of nodes. There we go. Yeah. And then well, because so what I'm thinking of is like we could do something like for neighbor in node.neighbors, we do a recursion like process node or something, or process neighbor or something, right? But then that won't really work because then that's how you get to infinite loops. So I guess we have to cache this first. Cache of new node. Oops. On cache of node is equal to new node. Because these are just references anyway. So maybe that's not a cache. That's a reference. So maybe that's a terrible name. But let's call reference. Changing names. So that in this case, when it goes to loop again, it should have the right reference. So now that then it should be okay. So self dot node or new node dot neighbors dot append process neighbor. I think that should be mostly good. Let's give it a go. Not gonna lie, this throws me off a little bit because it's not a standard algorithm problem, but it could very well be an interview question. I haven't seen anything like this, but yeah, it's possible. So let's give it a go. Let's run the tests. Oof. Oh, none. I guess I won't take the count that this is none. That's awkward. But how do I want to handle it? I mean, this can only happen if the node root is none. So let's just do it here. That's a weird edge case, but maybe that's okay. Okay, so let's give it a quick submit to see. It's not clear that it is good, but yeah, it's good. Yeah, so we only create each node once. So I think this is a tricky problem for me to explain a little bit. I mean, it's going to be, this is going to be this is linear time, linear space. You can't really do faster than that. Linear in the size of the input in this case, which is v plus e, which is number of vertex plus the number of edges. It's linear in that size, and also in space as well, v plus e, because you can't do better than that. You have to return that as the result, right? The thing that's tricky for me to explain here is how this works, because basically we kind of cache this as a reference, but the key thing to note is that the reason why this works is because these references are, when we have it here, unlike, like, you may try to think of it like dynamic programming, but it fails because that analogy doesn't hold, in the sense that these are weak reference, or they're not weak, they're references. So, and they're partial objects until they return at the very end. I mean, even then, they're still partial objects sometimes. So then you have to kind of draw out the graph to kind of convince yourself that this is right. But basically the idea is that let's start with two nodes, right? Let's say you have a 1 and 2 is connected, right? So what happened is, now what this does is that it creates a node of 1, and then it creates a link, or it adds to the neighbor, and then this recursion stuff, right? So then it wants to add a neighbor of 2, but then 2, its neighbor has a 1 too, right? So if you do it naively, you may get the infinite loop like this, because they're each other's neighbor, because it's undirected, right? But then the thing is that I have this thing, right? If node is in reference, we return it. So instead of creating a new node of 1, this loops back to our reference, which is this original node right here. Even though this node, as you might know, because it's earlier on the stack, it's not done yet, right? We haven't completed the node 1, but this contains a reference to it regardless. And when it does this, when this returns, then node 2's neighbors would contain a reference to all the nodes. So that's kind of how this code works. And I think the tricky part for me to explain in general for problems like this is that, especially in Python, something like this actually is going to be true in Java, depending on how you do it, or C++. But the thing is, C++ and Java, well, more C++, is that there are concepts of pointers and stuff like that, and it's more intuitive to kind of like, you need like a better understanding of how pointers work and stuff like that to understand, because the way that I did this here is very atypical, and probably, to be honest, very not Pythonic, but so if you have trouble with this, let me know in the comments or in Discord. I don't quite have experience explaining this problem, how this code works and how my logic goes with respect to references and pointers and stuff like that. But suffice to say that as long as we have the pointers, then you can kind of point in them in different ways. And also, of course, this can actually also be in an array, so you can actually point it to an array of references, which doesn't really explain things any easier, to be honest. But yeah, let me know what you think. Let me know how you did this problem, and maybe that you have a cleaner way of doing it. Let me know. As I said, this is a very non-standard problem in competitive, so I mean, I'm able to solve it, but I don't know how to explain it in a way that is very easy for beginners. Let me know how you think. Let me know how you feel, and I will talk to y'all tomorrow. Bye bye.